Hello and welcome to the 2015 Paper 2, Section A, Question 6. Okay, so this question is on statistics / correlation, etc. So let's read through it and get stuck in. There's a 20 marker and it's split into D scales, so 0, 5 for low partial, mid partial 10, high partial 15 and 20 full marks. Okay, so as part A here says mark 10 or more points on each of the scatter graphs below to show an example of the types of correlation named under each graph. So they want 10 or more, so you have to at least give them 10, or you'll risk losing marks. So here on the side of the case, so say we haven't to bother doing it on the graph as such. This here is a positive correlation between two variables. Doesn't matter what the variables might be, okay? It could be, your age versus height or something, okay? It's irrelevant in this scenario. But if you see here now, the points that you have going along are not in perfect correlation, okay, but there's a positive trend happening here. Now, perfect correlation will be literally one after another. If you can see those dots appearing, okay? That would be a perfect correlation. A correlation will be scored between 1, +1, and -1. Okay, so a negative correlation, getting closer to -1, is in the downward direction, so a negative slope. And lastly here, no correlation, there's no pattern to the dots. So strong positive correlation, we said there, would be a line, maybe we have 10 dots here, whatever. Something like that, okay. Strong negative correlation, here 10 dots close by here, if you can see them. And then no correlation, you have dots, just all 10 dots all over the screen. So you know what you're doing, pretty simple, okay, a lot of marks, okay. Now, parts A, 1, 2, and 3. Now, it says 25 marks here, and I'm taking this 20 marks here from the marking scheme. Actually, it's part B, that's what it is, sorry. Okay, so what you take down, or just take cognizance of what I'm saying there on the theory on the side. Then moving on to part B here, okay. Now, a few days before the Scottish independence referendum in September 2014, YouGov poll estimated the support for the no campaign to be 54%. Now, I would write that down here straight away. Okay, 54%. I won't get that marks for it necessarily because it's part of the text in the question. Now, if YouGov sampled 1,000 people, find the margin of error, write your answer as a percentage, correct to 1 decimal place. So don't need to worry about that too much till the end. We're looking here for the margin of error. Now, if you know your formulas, okay, you can go to the maths tables and you'll find the margin of error. Okay, formula. Okay, now I should be able to do that here on the digital version of the maths tables. Just bear with me while I find it. And here we are. Okay, so this is the maths tables here. Let's look at the contents page. And we'll try to find it here under statistics probability. I can page 33. Okay, let's see now. Go down. So you're looking at your formulas here. Margin of error should be one of these here. Okay, 1 over. Go to the next page. Actually, I assumed it would be one of the formulas here. Go back and see that I miss it. Okay, I apologize, I thought it was given in the maths tables, okay. But at this particular second I'm not finding it. There's standard error there, but it's not margin of error. Sure it's in there. Maybe I'm on the right page. Can't see that here too far beyond it. Okay, anyway, the margin of error formula is given here. 1 over square root of n. So as n increases, that the margin of error will increase. Okay, sorry, the other way around. As n decreases, the margin of error will increase. Okay, so for smaller sample sizes, there's a larger chance of being error. So in this case, our sample size was 1,000. So n equals 1,000. Okay, no, actually I have that done on the next page. Let's go to it. So your formula is 1 over square root of n. N is 1,000. put the 1000 in instead of n, you get 1 divided by the square root of 1000. That comes out to be 0.03162. Now they ask us to write that as a percentage, so you multiply by 100, I end up with 3.162. To one decimal place, I look at the 6, and I round back. The prior number 1 goes up, so you end up at 3.2%. Okay, so that's the margin of error, so that's worth 5 marks there. Okay, now the next part here, part 2, create a 95% confidence interval for the level of support for the no campaign. So we know the level of support was 54%. Okay, we were told that in the text of the question. Now we're looking at the margin of error then is 3.2% less than it. Okay, or 3.2% greater than it. Okay, now to phrase that a proper way, you want to put in your takeaway, the 3.2%, you have 50.8, so the probability of the 54% could be as low as 50.8% of the population support no, or as high as 57.2 based on the margin of error. And that's basically what a confidence interval is. Okay. Now, I stop at that. Okay, apologies for not being able to find the formula in the maths tables. I know it's in there somewhere. It's worth having a look yourself to try to find it and be familiar with it. But if it's not there, and maybe I'm wrong, it's a formula you've got to memorize. So it's margin of error equals 1 over square root of n. Thanks for your time.